Hey guys, so today is Monday, October 17th, and I'll be out today. I'm out sick. I hope you guys are doing great. You'll be receiving this Math 1 Unit 3 packet. You will be working with a sub today, so please be mindful, be kind, and get your work done. When you receive your packet, make sure that you will start by writing your name on it and the class period on top on the first page of the packet or the cover page of the packet. Then as you move on, you remember your lesson targets or your learning targets. These I've seen recently that some of you have completed them and others have not. So please keep those in mind. And as you get closer and closer toward the end of the unit, start completing them, especially once you finish the unit and you know how well or you did on an item or a target and how not so well maybe, or if you still need help on another target. So please make sure you rate yourself. Okay, it's important for you to do that in order for your packet to be complete. After the page that is after is basically your calendar mapped for you. And today, as you can see, you're doing lesson 3.1. So today you're doing 3.1. If you have me tomorrow on Tuesday, you will be completing lesson 3.1 and we will be starting on 3.2. And also we will be having homework tomorrow or the day after, depending on when you meet with me. For tonight, you will not be having any homework. I would, I would strongly advise you continue to work on 3.1 though. This is the calendar, and there's a blank page, so make sure you make use of these blank pages. They're intended for them to be there for you to take notes. After that, just our assignments, assignment sheet. So again, this unit is pretty short. You can see that it starts this Monday and it's done in 2 weeks. So on Monday, 10/24, next Monday, you'll be having your Unit 3 quiz, and the Monday that follows will be Unit 3 test. Keep those major dates in mind. And the homework assignments. So then a quick reflection. What I did here is I modified this page a little bit, and I added a reflection. Once you're done again with the unit, please make sure you sign. And you place your signature here, and I will give you a score. And also take a moment to write a reflection. How well did you think you did on this unit? What are areas you feel you can improve on, and so on. So make sure you write a brief reflection. This will happen at the end of the unit again. And now here, the page after, I said show your work for warm-up day 1 through day 5. So the page after this is warm-up. And I left you the page before it as empty space for you to use for your warm-ups. So today's warm-up, what you're starting today is with day 1 warm-up, and you will be taking the next few minutes to complete this warm-up. So the first question on the warm-up says, write an exponential decay function that passes through the points 0, 3, and 2, 3/4 or 3/4. So this is the first question of today's warm-up. And the second question is write a linear function in function notation that passes through the points 2, 5, and 4, 11. So you have 2 questions. Feel free to work, I would say, if you want to complete the first one on your own and maybe the second one with a partner, or both questions with on your own, that's also fine. But this is the warm-up for today. So take a few minutes, pause this video, and complete the warm-up. Now, again, the page after this is intended for notes. I left you a blank page for you to write notes. So every time I'm writing extra notes on the board, this page would help you document your notes. Today's lesson is 3.1, which is on identifying and graphing sequences. So what is a sequence? We've been dealing with patterns, which are very similar to sequences. The essential question here is, what is the sequence and how are sequences and functions related? So it says a go-kart racing track charges $5 for a go-kart license and $2 for each lap. If you list the charge for 1 lap, 2 laps, 3 laps, and so on in order, the list forms a sequence of numbers. So basically, when you have a list of numbers that are in a certain order, that have a pattern, right, in an order, that would be called a sequence, and they're basically comma separated. So notice here 7, then comma 9, then comma 11, then comma 13, and then dot, 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 3 dots to say it continues. And this is what a sequence is going to look like. So the definition, a sequence is a list of numbers in a specific order. Each element in a sequence is called a term. So here, in this case, 7 would be a term, 9 would be the second term, and 11 will be the third term, and so on. 13 will be the fourth term, and so on. 7 will be the first term, right? So in a sequence, each term has a position. In the sequence 7, 9, 11, 13, we just said that the second term is 9, so its position number is 2. So basically, 9 is the second term, and so on. 11 is the third, 7 will be the first, etc. The total cost, total cost, which is term, of riding a go-kart for different numbers of laps, which are the positions, is shown below. Complete the table. So basically, the position number is n, the first position, second position, third position, and so on. And the term of the sequence, which is the function, right, which is the cost, is 7, then for the first, for one, basically 1 lap. So remember, this is lap number, and this is basically cost, which is like domain and range. So 1 lap costs $7, 2 laps cost $9, 3 laps would cost 11. Notice that the pattern is add 2, then add 2 again, right, to get, let me just make it look like plus, and so on. So every time we're adding 2 here, okay, every time we're adding 2, as you can see. And then if I add 2 to 13, I get 15, and so on. And the position number means the lap number. In this case is 1, 2, 3, 4, 5, and 6. Okay, so make sure you write this down. Make sure you fill the packet as I go over the information. Part B says you can use the term and position number of a sequence to write a function. So from this pattern, we can make a function using function notation. Remember, function notation is f of x, right? This is function notation. F of 2 equals to 9 indicates that the second term is 9. So f of 2 equals to 9 tells me that for x equals to 2, or in this case for n equals to 2, f of n is 9. Use the table to complete the following statements. So f of 1 should be 7. F of 3 should be 11. F of 6 should be 17. Now we're saying f of what is 13? Remember, f is the y value, so this is the y value. So what x value, or in this case n value, would give you 13? If I want to get 13, n must be 4. So I'm saying f of 4 is 13. And similarly, f of 5 is 15. Okay, now identify the domain of the function f of n. So what is the domain here? Remember, the domain was the position number. And the position number here was what? It was for a different number of laps, right? So what is the domain? We can say if we start with 1 lap or maybe 0 laps, right? So we can do 1.5 laps, right? Technically, in this case, the laps are more discrete. So we can say 1, 2, 3, 4, 5, 6, etc. I would personally say 0 laps. It's possible to have 0 laps, and then 1 lap, and then 2 laps, and 3 laps, 2 laps, 3 laps, etc. Right? So, and so on. Now, if this were to continue, we would write this down. If we're talking specifically about this function, if we're talking about just 6 of them, right, then the domain would be specifically what's in the table, which is 1, 2, 3, 4, 5, 6. So make sure you always understand the context of the question. In this specific question, the domain is 1, 2, 3, 4, 5, 6. But it could be that there's more, right? There are more laps. Or it could be that with no laps, you pay $5, which could be like the initial value, or maybe like an initial fee of $5 without having taken or going any laps. So this is the domain. The range, in this case, would be the corresponding y values, which are 7, 9, 11, 13, 15, and 17, okay, of this function, f of n, right? Now, we can keep going again, right? But it depends on the values. I mean, we can keep going, but in this, if we're talking about this specific example, then the range is the one that I just wrote down. Now moving to reflection and discussion. Discussion, what does f of 4 mean? It means that, let me put it in text here, and be careful when they ask you about context. It means that, I would say f of 4 equals to 13 means that for 4 laps, the cost is $13. Okay. So make sure you write correctly and then explain how to find the missing value in the table. So, or values. So it depends. We're adding 2, right? You can say for f of n, comma, add 2, when x, or an n here in this case, right? When n increases by 1. Or as n increases by 1. So we're adding 2 to the y value, right? As the n value goes up when. Okay, so just make sure that you try to remember it's f of n in this case, right? It's not f of x. Now, communicate mathematical ideas. Explain why the relationship between the position numbers and the corresponding terms of a sequence can be considered a function. Why is it a function? Why can we consider this a function? If you recall, what is the definition of a function? So a function is a relation where for each, you can see here, so remember when we said a function is a relation that has what? For each value of x, there's at most, right, 1 value for y. So here you can say for each value of n, comma, there is at most, some of you will say unique, that's fine. In parentheses, right? So that means, for instance, you cannot have 3 laps and 3 laps cost you, let's say, what was it? 1 lap cost 7. So it cannot, 1 lap cannot cost you $7 and at the same time cost you $9, right? That's what that means. That's how we know it is a function. All right, good. So that's, make sure you complete this page. Now, the second page, page 2, explain 1, generating sequences using an explicit rule. So this is new information. An explicit rule for a sequence defines the nth term, right, of a function. It's very much like saying the general, like f of x, right, mx plus b, or whatever the rule is. So here, the explicit rule defines the nth term as a function of n for any whole number n greater than 0. Now, remember, in this case, in this unit, in this chapter or unit, which is on sequences, we're not dealing with negative terms. We're not dealing with negative. Now, unlike with functions where x can be negative, here, because n is the number of term, we don't have the 0th term, right? And we don't have the negative first term. So notice for this unit, the n values are going to be the first term, the second term, the third term, the fourth, and so on. So we're starting at 1 and moving up by 1, basically. And we don't have, you can't have the 2.5 term, right? So this is how different this unit is from the previous unit, from like mx plus b, or function that is exponential or whatever it is. So we're starting with the first term, right? And so on, and going up by 1, basically. So explicit rules can be used to find any specific term in a sequence without finding any of the previous term. So an example, here it says, write the first 4 terms of the sequence defined by the explicit. So it's given, its explicit rule means it explicitly telling you what the function is, what the equation is, right? It's giving you the rule explicitly that has n in it. So it says, make a table and substitute values for n equals 1, 2, 3, 4 to find the first 4 terms. And they showed you basically how they did it. So they gave you the rule, and they're saying, apply this rule. For n equal to 1, you get 1 squared plus 2, which is 3. And that's what f of n is. For n equals to 2, take 2 and plug it in this, right? You get 2 squared plus 2, which is here, and that's 6. 2 squared is 4 plus 2 is 6. And then for n equals 3, you do the same thing. 3 squared is 9 plus 2 is 11, and so on. For n equal to 4, you get 4 squared plus 2, which is 18. And now this is your rule. These are your values. Now it says the first 4 terms of the sequence defined by explicit rule f of n equals are what? So the first 4 terms of this sequence are 3, 6, 11, and 18. They happen to be that. Now, again, they don't have to be jumping by 3 or by, right? It could be any rule. So this specific sequence has this rule, and the resulting terms, first term through fourth term, are 3, 6, 11, and 18 consecutively. So then there's another part B, another sequence, 3n squared plus 1. It says make a table and substitute values for n equals, right? So what are we doing here? We're substituting for n equals 1, 2, 3, and 4, like we did with A. So if we have for n equal to 1, we get f of 1 equals 3 times 1 squared plus 1. 1 squared is 1 times 3 is 3 plus 1 is 4. So f of 1 is 4. Then f of 2, plug in 2 for n. So again, remember, this was the importance of having a parenthesis in front of the number. And I've been stressing the importance of that for maybe since the beginning of the school year. And now you're going to see why it's important. So we're going to do 2 squared first, which is 4. 4 times 3 is 12 plus 1 is 13. So f of 2 is 13. And again, f of 3, 3 squared is 9 times 3 is 27 plus 1 is 28. And this is 28. And then f of 4 is 3 multiplied by 4 squared. 4 squared is, you do 4 squared first, PEMDAS, which is 16. 4 squared is 16 times 3 is 48, plus 1 is 49. So this will be 49. F of 4 is 49, and so on. Communicate mathematical ideas. Explain how to find the 20th term of the sequence defined by, right, explicit rule. So you can say plug in 20 for n, right? And if they wanted you to do it, you would say f of n, or f of 20 here, is what? Is going to be 20 squared plus 2. And you do 20 squared, which is 400, plus 2, which is 402. So it's very much like solving for an equation, or like evaluating an equation. But in this case, we're dealing with natural numbers, right? We call them n values, 1, 2, 3, 4, etc. There's no negatives. There's no 1.5 or 3/2, which is kind of nice not to have fractions for a while. Now, justify reasoning. The number 125 is a term of the sequence. So they're saying when they say the number 125 is a term, that means 125 is here somewhere. It's not x or it's not n in this case, it's f of n, it's the value, it's the y value. But for this rule, is a term of the sequence defined by the explicit rule, right? F of n equals 3n plus 2. Which term is it? So what is n? So when they say the number 120 is a term, right? Which term is in the sequence is 125? So how do you do that? Instead of, you're not replacing n by 125, you're saying the value, right? You're saying the value. So it wasn't very clear. It should have been the value or f of n. So what you're saying here, you're saying 125 equals 3n plus 2. That's what you're doing. You're replacing f of n by 125. And if you subtract 2 from both sides, you get 123 equals to 3n. And if you divide by 3 both sides, you get n equals, this is an error, you get an n equals to 41. So basically the 41st term, right, if n is 41, 3 times 41 plus 2 will give us what? 125. That's what we're saying. So again, when they tell you the value is 125, you erase f of n and you replace it by 125, not n, right? So this is how this part works. Moving on. Next is, let's try your turn on your own. Write the first 4 terms of the sequence defined by the explicit rule, f of n equals n squared minus 5. So write the first 4 terms, f of 1, then f of 2, very much like they did with it, or we did with a table, right? Same thing like here, f of 1, f of 2, f of 3, f of 4. And then again, it says find the 15th term. So that's when n. When they say 15th term, or the first term, or the 10th term, or that's n equals to That's n equal to 15, right? So of the sequence defined by the explicit rule, that means take 15 and replace it in here for n. So f of 15, and again, of course, you're going to replace it here, and that will give you the value. So take a moment and do this. Okay, maybe pause the video and take a minute. Just complete this 6 and 7, and then resume with the next page. For the next page, it says generating sequences using a recursive rule. And by the way, if you're not done, if by the time this class is over, the class is dismissed, you're not done with this video, it's okay. Just finish it at home, okay? Just make sure you complete it at home so you understand the lesson completely. Now, the second thing, we just talked about explicit rule, right? Now we're doing recursive rule. Recursive rule for a sequence defines the nth term by relating it to one or more previous terms. So explicit, it relates it to the term itself, to the variable, like f of x equals mx plus b. This is explicit. You know x, you know y, right? If you have the value of x, you know the value of y. That is explicit. But recursive is not as straightforward, is not as explicit, right? It's recursive. That means it needs something from the previous term or a different term, right? For you to find the term, the current term. An example of this would be f of 1 is equal to 4. I'm telling you the first term is 4. That's what that means. The first term is 4. And I'm telling you any term f of n, right? F of n is what? Is equal f of n minus 1. F of n minus 1 means the previous term. So f of n is the current term. And you'll see in a moment how. And then plus 10, according to this. And this is one example, right? So for example, so you understand this better. Let's say n is 3, right? This becomes, f of n becomes f of 3 is equal to what? F of n minus 1. N is 3, so n minus 1 is 2 plus 10. What does this mean? This, and again, I use this as a random example. This means if I want the third term, if I want f of 3, I'm going to need the second term, which is f of 2, and then I'm going to add to that what? I'm going to add to it 10. So notice in this type of rule, which is the recursive rule, to find a term, you need to rely on the previous term and then something, right? Add to it, multiply it by something, and so on. So let's try this, right? That's right. And here it says this rule means that after the first term, we know the first term, but anything after that will rely on the previous term. So if I want f of 2, I'm going to rely on f of 1 because 2 minus 1 is 1 plus 10, which means the second term is equal to the first term and add 10 to it, and so on. The third term is going to be the second term, add 10 to it, which is what I had here. The fourth term is going to be what? Is going to be the third term, add 10 to it, etc. Okay, so it's like the domino effect. You get the first term, it helps you with the second helps you with the third helps you with the fourth, etc. So with this being said, let's try A. A says f of 1, the first term is 2. And it's telling me the current term, f of n, is the previous term, f of n minus 1 plus 3. So let's find, where do we start? We start with f of, so we know f of 1 is 2. How do I find f of 2? F of 2, the second term, is, if this is 2, this becomes 2 minus 1, right? Which is f of 1 plus 3. But I already know what f of 1 is, the first term. I know it's 2, so it's 2 plus 3, which is what? Which is 5. And that's exactly what they got here for the second term. Now, if I want the third term, f of 3, it's f of n minus 1, f of 3 minus 1, which is f of 2, aka the second term, plus 3. So I would get 5 for the second term plus 3, which is 8, and so on. And this is what they did here, and they continued and they got 11. So the first 4 terms for this sequence are what? They're 2, 5, 8, and 11. Now this was A. B is similar, more practice, more of the same. So for f of 1, it says f of 1 is equal to 4. The first term is 4. And any terms thereafter, f of n, is f of n minus 1, which is the previous term, plus 5. So if I want f of 2, remember, because I have f of 1, so then that's why I start with f of 2, the second term, because I know the first term from here. So f of 2 is going to be what? If 2 is n, right? That's how I get f of 2. This will become f of 2 minus 1, which is f of 1 plus 5. And I know f of 1 is 4, the first term, and add 5 to it, which is going to be 9. So this is going to be, excuse me, f of 1, the first term is 4, which is here. F of 1 is 4. F of 2 is f of 1 plus 5, and f of 1 is, we just said it's 4 plus 5, which is 9. Now f of 3 is going to be f of 2 plus 5, and f of 2 is 9. 9 plus 5 is 14. This was 9. This is 14. Again, f of 4 is f of 3 plus 5, and f of 3 is 14. 14 plus 5 is what? I should put it here first, 19. So the first 4 terms are what? Are 4, 9, 14, and what? 19. And notice, this is starting by 4 at 4 and adding 5 every time. It just happens to be like that, right? And the adding 5, remember, it looks like right here, you're just adding 5. That's what it is. So reflect, describe how to find the 12th term in example 2a. I'm assuming this a here was 2a. Yeah, this is 2a. So how do you find the 12th term? How do you find the 12th term in here? Well, if you want f of 12, that's going to be f of 11 plus 3. So for you to find the 12th term, you need the 11th term and add to it 3. So I would say here in words, to find the 12th term, we need to have, or you can say, we add 3 to the 11th term. See, so some of you will say, but I don't know the 11th term. Well, you need to find the 10th term, and I don't know the 10th. I need to find the 9th term, and so on, all the way back to the first term, which is always, by the way, given, right? This will be given to you, the first term, just for you to know that, oh, what if I don't have any terms? No, you will have at least the first term or one term. So that's how the reflection on 2a works, or number 8 in this case. Number 9, suppose you want to find the 40th term of a sequence. Would you rather use a recursive rule or an explicit rule? Explain. So if you want to find the 40th term, do you really want to go back to finding the 39th term and the 38th term and the 37th term all the way back to the first term? Or would you like to have an explicit rule, which has, let's say, f of n equals, let's say, 5n plus, let's say, 3. So if you want f of 40, you can automatically plug in 40 for n, and that will give you 5 times 40, which is 200, plus 3, which is 203. That's an example, right? But it's an example of an explicit rule. So notice which one it makes your life easier. Of course, the explicit rule, because you just plug in for the value you want. Okay, so to answer the question, I would say I would rather have, again, use the question to answer the question. I would rather use an explicit rule, because I would only need to plug in for the value of n, and here it's 40, right? Here it's 40, to find what? To find f of 40, or the 40th term, which is technically the 40th term, to find the 40th term. Okay, so it's not too difficult. It's just basically it's very much based on the equations of a line and mx plus b and things like that that you've done before. Not all of them are going to be linear, by the way, but sequences are very common. So your turn, on your own, try f of 1 equals 35, and the rule says f of n equals f of n minus 1 minus 2. And then for each whole number n greater than 1. That means when n is greater than 1, you're going to use this rule. When n is 1, we know f of 1 is 35. For when n is greater than 1, we're going to use this rule. So for 2, 3, 4, etc. And it's asking you to find the first 5 terms. So how do you find? I'm going to help you get started. F of 2, according to this rule, is f of 2 minus 1, which is f of 1 minus 2. And I already know f of 1 is 35, minus 2 is what? 33. So you need f of 2, f of 3, f of 4, f of 5. And you're going to do the same for number 11. So take a minute, pause the video, and try to work on this. If you have questions, ask in class, maybe collaborate with a classmate and get help. Okay, ask for help. So pause the video and work on numbers 10 and 11. If you're out of time, make sure you complete this at home. You continue watching the video at home and complete the lesson. And we will talk about this lesson more next time. So for the next part here, explain 3, constructing and graphing sequences. So you can graph a sequence on a coordinate plane by plotting the points n, f of n. Indicate a table that you use to generate the terms. So what I'm going to do here, I'm going to give you enough time. So I'll continue this video and you can have it so you can, whether you're finishing class and you have time, if you have time, just continue this lesson, okay? And if you don't, just pause where we landed here with your turn numbers 10 and 11, okay? So for this part, constructing and graphing sequences, you can graph a sequence on a coordinate plane by plotting the points n, f of n indicated in the table that you use to generate the terms. So you can plot them like x and y. These are very much like x and y. Like basically what you're saying for n equal to 1, the y value is 7. So you're saying 1, 7, which is right here. Then 2, 9, which is right here. Then 3, 11, which is right here. And 4, 13, which is right here. Okay, so that's how you plot them. These are points, right? They're just points. They're not connected. They're not lines because they're sequenced, right? There is sequence of, you're saying the first term is 7, the second term is 9, the third term is 11, the fourth term is 13. You're not saying this is number of lap. You're not saying the first and a half term is something. So these are not continuous. Just be careful with sequences. With this unit and sequences, your data are discrete values. They're dots. They're not connected lines. So here we can write them as ordered pairs. This is what I just said, which is basically 1, 7, 2, 9, 3, 11, 4, 13, etc. Then graph, I did graphing. And notice that the graph is a set of points that are not connected. Okay, keep that in mind. They're just set of points that are not connected. Now let's try one. We'll try number 13. Clear this. Number 13 says a pizza. I'm gonna try 13 and I'll have you try 14, okay? So even though it says your turn, but I'll try one more so you can see what's going on. A pizza place is having a special. If you order a large pizza for regular price $17, you can order any number of additional pizzas for $8.50 each. Use the recursive formula or rule, f of 1 equals 17. So we're going to use f of 1 equals 17. That means the first pizza is $17. And then any pizza thereafter, f of n equals what? F of n minus 1 plus what? $8.50. So this is saying any pizza is going to be equal to the price of the previous pizza plus what? Or any next pizza plus what? Plus $8.50. So, okay, let's see what that means. What are we looking for here? We're looking, let's try maybe, did they say how many values? Okay, they did not. So let's try f of 2. Let's start with f of 2 just like we normally do. F of 2 is going to be, if this is 2, this is going to be 2 minus 1, which is 1. It's going to be f of 1 plus 8.5. And f of 1 is already 17, we know that, plus 8.5 is 25.5. So we're saying 2 pizzas are going to cost us $25.50. The first pizza is 17, so this first pizza is about right here, $17. The second pizza is 25.5, a little bit above 25, just barely any. Then the third pizza, remember we're doing recursive, the third pizza is going to be the price of the second pizza and 8.5, or right? Or not second, like up to the second, I think. Two pizzas, I should say, not the second, which is 25 and a half, 25.5 plus 8.5, which is going to be 34. So to get 3 pizzas is going to be costing you what, $34, which is about right here, and so on. And 4 pizzas, yeah, each additional pizza, that's what it is. 4 pizzas is going to be the cost of 3 and 8.5, which is 34 plus 8.5, which is 42.5, and so on and so forth. So you're technically adding $8.5 every time. 4, 42.5, which is about right here. Notice, because I'm adding the same number, this is going to be a linear pattern. This happens to be, right? Not always it is, but this is just adding, right? Adding $8.5 every time. So it will be linear, and so on. But again, we're not connecting the dots. We're just keeping them dots in discrete values, okay? So try number 14 on your own. Now that you've seen numbers 12 and 13, try number 14 on your own. And then what I would like you to do, even though you don't really have homework, but try to think about these questions, and we can talk about them next time. 15 through 18, just try to think about what's happened this lesson, right? What have we learned? What is an explicit rule? What is the recursive rule? What's the difference between them? Try to think about and reflect on what we learned, and next time we will pick up where you left off here, and I'll give you the answers to questions 15 through 18 and the ones you've completed on your own, but attempt them. So this was the lesson for today. I hope that you complete it in class. If not, just finish it at home, and have a wonderful rest of the day, and I'll see you next time.